I know you can't answer, but I'm quite sure, I hope and believe we are all fine. I need someone to recap, to tell us briefly what we did in the other lesson before we begin today's lesson. There's Crown there, Mr. Chakon. Mr. Chakon.
Teacher.
Yes?
Okay, we did the factors affecting density.
Yes.
And there were two main factors, temperature and pressure.
Yes.
Then we started application of density in floating and sinking.
Okay. So what application did you talk about?
Okay, we did the experiment of the piece of wood in water, and also did the one of stone in water, whereby the stone sank because it had no density, but the wood was floating because it had less density.
The first one, the stone sank because?
It had more density than the water.
Okay, and?
Yeah, the wood floated because it had less density than the water.
Very good, Crown. I think she has summed it up very well. Maybe I can allow just one question, if any, before we move on.
We have Charity there.
It's there. For me, it is there. Looks like there's no question. I want to share the notes briefly so that we see how far we've gone and where we are going to share today. Now, probably, as I look for the notes, tell them what we've done.
Okay. As we look for the notes, concentrate on my video. I don't know whether you see Mr. Sanjovi's so-called stop sharing. Concentrate on this video. It is Mr. Sanjovi speaking. Do you see me? Girls?
Yes.
Yes, we can see you.
Yes,
you can see that dish, eh? Can you see that dish of water?
Yes.
This dish of water? Okay. Now look at the shape of this dish because we have two types of water. We want to, and then you see, what is this? Anybody who can tell me what this is?
Salt.
Iodized salt.
Is that okay?
Salt.
It is iodized salt.
Yes, so I'm going to pour salt into this water. And we have already put there some salt, but we wanted you to see that this water is salty. Is that okay?
Yes.
This is what salty water. So we are trying to stir it so that the salt dissolves in the water. So that is what we refer to as salt water. And the term that is going to be used is called such water. When there is salt in the water, there will be that term that is used to that will be used. It is called. Is that okay? When water is salty, we talk about its salinity, how much salt is in the water. So we have what we refer to as salty water in this dish, okay? And then we have, so this water we shall use this later, the salty water, but remember the shape of the dish, that is our salty water. We also have another dish here. I hope you see there, it is slightly wider. You remember that shape. Do you see the dish?
Yes, Mr.
Yes, please.
Okay.
Can you see this dish?
Yes, teacher.
Yes.
Okay, this dish here represents pure water. So we have water which is salted, and then we shall have water that is pure. I hope that is okay. You must also recall that when you make water impure, you affect its density. Do you remember that impurities affect density?
Yes. Yes.
Okay. So we have pure water. What is the density of pure water, girls? What is the approximately density of pure water, if you remember?
1 gram per
1
cubic
gram per
centimeter.
cc.
1 gram per
Beautiful.
meter.
So when we put in salt, what do you expect the density to be? Will it be the same?
No.
No.
No?
Will it be denser?
Yes, it will.
Yes, it will.
It will be denser because of the presence of impurities. Okay, impurities may reduce or may increase the density, but we are going to see this. So remember these two dishes. I want to hand over to Madame Javira so that she can now take over and remind us where we stopped. Thank you very much. Okay.
Thank you so much, Mr. Sendere. I think I'm now ready to share my screen. Now, like Crown told us, last time you went as far as comparing the densities of water, stone, and wood. And you found out that that which has a density less than water will float, and that which has a density greater than water sinks. Now, this is just a table of densities of common substances. We are not going to go through it now, but in your free time, you'll check and see, because the main question here is for you to predict whether a substance will sink in water or not. There's an assignment down here. You'll read through. We may not go through it now, because the example we did was elaborate. Now, when we move further down, you realize that we are talking about, they are showing us canoes. Probably I could have someone reading through from in West Nile. Anyone? There's a twin. A twin? Or is it Lena?
Atwine Stacy.
Lena Jiweji.
Yes.
Lena?
Please unmute.
Yes,
Okay,
please.
now unmuted her.
Got it. Got it.
Atwine? Okay, let me read for myself. Now, we are seeing that in West Nile, people living along the Nile use canoes made out of wood. The canoe is able to float on water. So they are asking, can you explain why? Is there anyone who can tell us why the canoes that are made out of wood float on water?
Mr. Chakuni, do you hear
Maybe
us?
he went off.
Okay.
Kirabo Eunice.
The reason why the canoes float on water is because they're less dense than the water.
Kirabo, I think I've unmuted you.
Yes. The reason why the both canoes float on water is because they're less dense than the water.
Yes, Kirabo.
The reason why the canoes float on water is because they're less dense than the water.
Very good. The canoes are made out of wood, and we found out that wood is less dense than water, so they will float. Now, moving down, most large are not made out of wood, but out of steel. We can see from the table, the other table I showed you. Let me show it again. Can we look at the density of steel? Is here, 7.9. Yet that of water is 1.0. So we definitely expect whatever is made out of steel to sink. So, how then can a large ship made out of steel float? That's the question. And we have examples here. Yvonne?
The ship has many other things, including air. Most of the space in the ship is air, and air and steel together has a less density than water. That's why the ships are able to float on water.
Okay, very good, Yvonne. Maybe before you go off, where exactly is the air? What position is the ship?
Okay, like I think like most parts of the ship is mostly air.
Okay, thank you, Yvonne, for your clarification. It is true, it is air. Now, I
think the how.
tell us exactly where that air is.
Teacher,
Yes.
may I think when they are making the ship, they make like the ship is big, making the volume large. So when the volume is large, it will affect the density, making it low for it to float.
Okay, that is okay, but remember it is made out of steel, which sinks. So much as the volume is big, the mass is also big because it is made out of steel. Yes, Kira.
I think the reason why the ship floats is because, like, you know how a ship in it has like some space at the base of the ship. I think that's where the air is. Yes.
Very good, brilliant. So I'm going to illustrate something here. Are you seeing that barrier? Are we seeing?
Yes. Yes.
Okay, so this is going to be my. Let me unshare. Yes. Okay, there we are. So this is going to be my. Then this is going to be my ship. So you notice when now this is an empty bottle. When I place it there, it floats. Like someone has here elaborated. At the base of the ship, we have empty space.
I can't.
Yes?
I can't see.
You can see it. Can you now see?
So now yes.
Oh, I think there. Okay, now we are doing this bottle is empty, and it is going to represent the base of the ship. So now I'm going to exert some weight. Remember, on top of the ship, there are other things, there are even hotels and the rest. There are even some ships, ferry vehicles. So as I'm pressing, it's still floating. But if I exceed a certain point, then the ship will sink. So much as they put the air down, there's a maximum weight that the ship can carry. Now I'm going to put some sand here. Now this is supposing we didn't have air at the base of the ship and the whole ship was full of other things. This is still floating a little. I'm requesting Mr. Senjebe to fill the other bottle with water so that we see what will happen. But as you can see, it is not floating as it was floating when it was empty. It is partially immersed.
I can't see anything.
You can't see.
Shall we? Shall we are only seeing letter E.
Teacher, you're off and on.
See.
Letter E from one.
There is an R U is either. Mr. Chakonye. These girls are over-occupying our screen.
Please, the girls, whoever is asking, can we allow the screen to be seen?
Teacher, I think it's because...
It's because of what?
Okay.
Okay, it's now okay.
There are so many people entering at the same time, being admitted. I don't know.
The girls have to stay muted so that Zoom does not switch to them.
Okay.
So girls, please, we are going to mute you.
And also the hands.
That's there yet. Oh my. I don't know what else can we do. I've muted all, but
Nantale is not muted.
sure.
Okay, let
Now,
me
can
pin
you mute yourself if you're not muted? For all of us to see what I'm trying to do.
No, let me spotlight you. Let me spotlight this for everyone. It's okay now.
Okay. Okay, thank you, Bruno. Now, that means I'm going back to the original point. This is representing our sea or our lake or our ocean, this bowl of water. And this here is representing the base of the ship. Remember, we say that the base of the ship, we should have on the air. That is when, much as the ship is made out of steel, the combination of air and steel eventually has a volume less than that of water. I mean, yes, a density, sorry, not volume. So if this is the base of the ship, remember on top of the ship, we have other things. So I'm going to exert pressure to represent the other things that are on top of it. Bruno, spotlight Mr. Senjave's laptop. Bruno?
Yes?
Please spotlight Mr. Senjave.
I'm trying to find him in the participant list. One moment. But their hands up. The hands.
Mr. Bruno?
I am right here.
Okay. Please spotlight Mr. Senjave's. My laptop has gone off.
Okay.
I'm using Mr. Senjave's to illustrate.
It's what we are viewing right now. We are viewing.
Okay, so you're viewing me, eh?
A bottle.
Okay, okay, very good. Okay, very good. So as I had mentioned, this empty bottle is representing the base of the ship made out of steel. Now, on top of the ship, usually there are other things. It could be wood, it could be metal. So my hand pressing down is replacing those other things. Now, if the weight of the things on top exceeds a certain limit, as you're seeing, the ship would sink. So much as the ship is wide and it has air below, there's a certain amount, a limit of weight that it can carry. Now, supposing instead the lower part didn't have air, or the amount of air is small below the ship, you would see what would happen. I've put some sand here, so we can see it sinks. Later. I'm saving time. Okay, now I have another bottle here, which is full of water. Supposing the base of the ship was all made out of steel and no air space, you can see clearly that it would sink. That is why at the base of the ship, there is air space to allow it to float. Now, the same thing happens to what we call submarines. Submarines have tanks. When they want the submarine to come up, then they empty the tank and it floats. When they want the submarine to sink down, then they fill the tanks with water and therefore the submarine sinks. So it is the same principle for ship and submarines. Let me pick, maybe you can pick a few questions. Mr. Chapon.
Madam, let me pick Codette here. Okay. I see Codette. Codette, can you please say something? If I can see your hand up. Codette? Okay. Codette may not be ready. Let's try Sally. Beta Sally.
There.
Okay. Their hands are down. I think we
just
can
continue.
Move ahead. Yes.
Okay, so what I've been illustrating is explaining why those large ships, much as they are made out of steel, float. They have low density because below them, they have a big space that is filled with air. So the combination of air and steel makes the density of the whole thing much smaller than that of water. So since there are no questions, we are going to move on to see what happens when an object is placed in pure water and when it is placed in salty water. What Mr. Senjobe started with.
Yeah, Madam Nampai.
Yes, please.
I wanted to suggest also that probably there is I have a small video also about ships, which now brings in the safety, conditions and what have you, how much load and stuff like that. I don't know if I could put it there as well.
Maybe you can share it. You share it right now before we move on.
Okay.
Or you want to put it on Google Classroom?
I think I can put it there as well. Maybe towards the end, if we have any minutes left, you can always put it there as we wrap up the lesson.
Okay, thank you.
Thank you.
I'm going to hand over to Mr. Senjobe to handle the next part.
Thank you.
So, girls, we started by looking at why ships float. We have looked at that, and basically we have said that ships are made hollow. That hollow space is filled with air. The amount of air reduces or makes the average density of the ship less than that of the water, and hence they can they can float. However,
yes, let's see what this girl is saying. Nyanzi, do you have anything to say? Hosanna, I see your hand up.
Yes, I have a question.
Okay, I think she's
yes, unmute her and she asks the question.
Out.
We have not had that question. Mr. Jaco, you have not had a question. There are many hands up, Mr. Jaco. Okay, I'm going to pick Lena Kiweji. I've unmuted you.
Teacher, you said that submarines to float again, they have to release water. But how do they release water without more water entering?
Okay. Submarines are specialized and they have special tanks called the ballast tanks. They are called ballast. I don't know if I can spell that word. It is B-A-A-A-S. B-A-L-L. They are special tanks. That is the spelling of the word ballast. I don't know if you can see it. So those tanks are specialized. You pump in water and you pump out water. Pumping in water, remember we have this. When we pump in water, the submarine sinks. When we get out water, I'm going to pour out the water. I'm going to pour it. Now you tell me the level of sinking. The submarine decreases the level of sinking. So as you reduce the water and you make it more hollow, you increase the air space, the density of the submarine decreases compared to that of the water, and therefore the submarine is able to come to the top. So that compartment is a specialized compartment, and it is not exposed to where the people are. I think that's where your major concern is. There are specialized tanks somewhere at the bottom that allow in water and pump out water. Okay?
Okay.
Okay. I see very many hands, Mr. Chakonyi. I don't want us to leave these questions unanswered. There is Gloria. I am unmuting. Gloria Lakicha, something like Lakicha.
Teacher.
Yes, please.
The reason why ships made out of steel float, can you say that because it's hollow?
Yes, they are hollow and they are hollow and they have a lot of air, and the average density of the ship, including the air, is less than the water or the liquid, the water in which it is floating in.
Okay, thank you.
Okay. There is Sally. Sally has gone off. Sally. Sally, what is your question? Sally, what is your question?
In the water representing the ocean, because last time we talked about how different ships go for different types of, like, you talked about how different ships go to different types of, they're supposed to go to different types of water bodies.
Yes. So that is what we are going to demonstrate here in the next experiment, where we have a lot of salty water and we have pure water. So depending on the density of the seabody, of the water body the ship has gone in, its level of sinking will be determined by the quantity or how salty that water body is.
Okay, thank you.
Okay. Do we still have, I think we are, I don't know, other people, I think we are going to move to the next level. I don't know what you suggest, Mr. Chakonye, because there are so many, yet we want to accomplish something. I think we have tried to answer as many questions as are possible related to this topic. One more, okay. Now, this blow, is it, what? Hosanna? Nanya Hosanna, what's the question? Yes, please.
I have a question.
Yes, ask the question.
Teacher, like about like floating, like a cruise ship, it's like a cruise ship is like made out of like steel. Then after that they add in like many people, like even like 200 plus add on the weight
of the ship. Yes.
Then how is it like able to continue like floating on water? Like the number of people increase, that is like also.
Okay, this is what we have said.
Let me answer that.
Yes, please. Thank you.
Teacher, I think like when they put the air down, the ship, it makes the density low. Now the way that you put, even the weight of the people is included there.
Yeah. Okay. Okay. There is a maximum load. For every ship, there is a maximum load. Mr. Chakonye is going to display that later, because there must be a maximum load. If you exceed that load, you are endangering the ship. The more weight you put, the ship sinks further into the water. So if you exceed the weight that has been recommended, you are endangering everyone on that ship, and the ship is likely to sink. Because we have seen that the more weight you add, the more it sinks into the water. Look at this bottle, it has water, it is sinking. Can you do my video? Okay. Can you concentrate on that video which I'm trying to display? This bottle is sinking because it has some weight, but if we empty it, it sinks less because it hasn't got a lot of weight. Now, if it is filled with water, or I press it down, I put a lot of force, it will sink. So there is a limit to the weight a ship must carry, otherwise you may endanger the people on it, everyone on that ship. And I hope Mr. Chakoni will display that video. Let us be as quick as possible so that you fully get the concept. Why you never know, some of you may become whatever people who handle ships, and you need this knowledge.
Teacher, I can add something.
Yes, add.
We all remember the incident of the ship that sank in the Lake Victoria.
Very good.
It was said that the weight of the people and the party that was going on was more than the weight was more than that was supposed to be on the ship, and they were said that there was some hole that was under the base of the ship, and so the weight of the people and the water that was entering into the ship made the ship way more than the weight of the water that led to the sinking of the ship, and many people died.
Oh,
that is very.
Who is this one?
Very nice example.
Who is this lady, Banagi? She needs a hug. If mom is there, please tell whoever is around to hug you. That was very brilliant. I hope she has explained everything we want to say. Is that okay, people?
Yes.
I can see the
okay, the
hands.
hands I think have gone down. There is except okay, she has also disappeared. Very good. So can we now move to the next point?
Yes.
Okay, Madam Jeffrey, share the notes. Okay, for me, I'm going to remove my video. Yes, floating in the sea. Okay. So we have seawater. We have said that seawater.
So we either first read or.
Okay, they first read. Who is the host?
Okay, we have floating in the sea. I could just read through to save time. We have the density of water is greater than the density of fresh water. I mean the density of seawater is greater than the density of fresh water because of the salt dissolved in it. The density of seawater is about 1.03, and we are required to try the next activity that uses seawater and see if we can prove what they've just mentioned. So that is what we have. We have a small block of wood. We have two different barrels, one with fresh water to represent the seawater, and then the other one with the salt, the one we showed you, to represent the salty water or the oceans. So we've already put the water in the barrels. We are going to see where the floating, we need to notice where it floats most or where it sinks most between the two barrels. So I'm going to unshare this so that we go back to Mr. Senjo.
Okay. Separate on this video. And remember, this is the salty water. I hope you can still see the salt in it. This shape of the barrel, and then this water here in this jar. Now, this is the pure water. So, this is our piece of wood. I hope you can see the piece of wood. It's a floating object. And I'm first going to place it in pure water. So, make the observation clearly, and because it is a comparison. So, we have placed it in that water. That's the far it can see. I hope you can see that.
Yes.
Have you made that observation if I was on this video? Mr. Bruno, if you can make the video more prominent. So that is the level of sinking. I want to move this wood now, and I put it in the salty water.
Okay. It's sunk halfway. I'm going to mark the level of sinking using a piece of chalk.
Okay.
So it's sunk halfway. I don't know that you can see.
I don't know whether I see that.
That is how far it sunk down.
Now we are changing this power, we are bringing in the salty water. And then we get the same piece of wood, and we are now going to place it in the salty water. So let us see the level of sinking. It's small, but it's there. Unfortunately, most of us don't know whatever, but me, I observe that there is a slight change in the sinking. Okay, so what can we say about the salty water and the pure water?
The block of wood.
Now, Mr. Senjoro is going to get another piece of wood, a similar one, and I'm also trying to stir this salt so that it dissolves a little more. So we shall just hold on a bit as he brings the other block of wood. We underestimated the salt. We thought we could dissolve it today and it dissolves, otherwise we would have done it yesterday. But we wanted to see you, we wanted you to see us dissolving the salt there. So actually you can try this at home. This is very easy to try. You don't need a glass bowl if it is not there. Just get a bowl that is wide enough and something that can float, a small piece of wood that can float. So you fill one of the bowls with, you need to put a lot of salt for the effect to be seen. Okay, Mr. Sendero is here. I don't know whether we are seeing both.
Can we see both pieces of wood?
No.
No.
But some people are raising their hands.
No, we can't see them.
Insima.
They are not clear.
Insima, you have something to say?
Teacher, I observed that the block of wood floats higher. Yes, teacher.
Okay, probably she forgot the hand.
I observed that the block of wood floats higher in salt water than in fresh water.
It does what? Come again.
The block of wood floats higher in salt water than in fresh water.
Okay, that is Nsima's observation. Noted. Thank you. Let me pick someone else. Joy Mary.
I think that the block of wood floats more on the salt water is because like the salt water has impurities which make it more dense.
Good. She has even explained why. Beata.
If the block of wood on salt water floats higher, does that mean it can take more load?
Yes, it can take more load. Yes, that is exactly what it means. That if a ship is sailing on salt water, then it can carry more weight than when it is floating on fresh water. That is very, very
Okay, thank you.
Any other person? Daniela here.
I can see the block of wood floats higher in the salty water, the pure water, because salty water has impurities, which makes it denser.
Good. Okay, Daniela, thank you for that. Vanessa, you have something?
Teacher, I'm asking a question. If like I've seen that the block of wood has like in the pure water has sunk a little bit, isn't it supposed to be floating all the way since it's less dense than the water?
You want it to float completely. That is what you're trying to say. That it should not even.
Yeah, I'm just asking.
Now, remember, this is not pure water. We simply picked it from the tap. And also, but also, let Mr. Senjobe add to that.
Okay. Whenever you are in a fluid, there is a part of you that goes below the surface of the fluid, and another part remains above the fluid. So the part that goes below the fluid is said to be submerged. Now the part that stays above, okay, the part that goes below the liquid is referred to as being submerged. Now we see that if we look at this piece of wood in pure water, the fraction of it that is below the water's surface is less than that, or is more than that which is in the salted water. There is more submersion in fresh water than in salted water, meaning that salted water is more dense, therefore it can support larger weights compared to pure water, which is slightly less dense, and therefore it cannot support very heavy weights. In case it is a ship is likely to sink more in fresh water than in salty water. That's what you're trying to bring out.
Actually, I think that is what Beata mentioned. She asked it like a question to confirm that whether the ship in salty water can carry more weight as compared to fresh water. I have a word for Crown here. Crown?
I have a question.
Yes.
Okay, does that mean if I kept adding more salt, the density would increase?
If you're asking whether if you kept adding more salt, the density will increase?
Of the water would increase, yeah.
Of the salty water?
Yeah, salinity, that is another factor. Impurities can increase the density of water.
Will it reach a point where stone could float on water?
She's asking whether if she puts in more salt, it will float higher than it is.
But there will be a limit also.
I'm asking if it would reach a point where...
Yes?
I'm asking if it would reach a point where it could allow stone to float, a stone.
No. No. The stone, still the density of, by the way, the density of salty water is just above 1.0 something. 0.03, I think. Yet that of stone is 2.85 like we saw, so it cannot allow a stone to float.
Excuse me.
Crown still, or who is talking?
Teacher, does it mean that the more the water is salty, the more the things float?
The more the what?
The more things float on it.
No, like we've mentioned, salty water, however much salt you put, there will be a limit to its density. It will not go beyond 1.03. The density of salty water or salinity is 1.03. So you're adding more salt does not mean that it will now increase the density more.
Okay.
I hope I've answered your question. There's a limit beyond which it can't go. And Agano Queen.
I was asking,
yes,
if
if like you put sand in water and it increases its density, will the piece of wood will still float?
Does sand, what is the difference between sand and salt in regards to the mixtures? When you mix sand with water, and then when you mix salt with water, what difference do you see there? Lagana, before I answer your question.
Teacher, like the water becomes muddy water.
That is
Sand does not.
Sand and mud. Does sand dissolve in water?
No.
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 Therefore,
Okay.
can you try answering your own question?
Yes, teacher.
Mrs. Nampaj.
Yes. Yes, please, Mr. Sali, are you the one there? Oh, Mr. Chakon.
Mrs. Nampaj.
Yes, please. Mr. Chakon, I think you're the one.
I think that student might be relating sand to salt, thinking that because salt dissolves in water. Yes, please. Are you hearing me?
Yes, we can.
Okay, I suspect that student is relating sand to salt.
Yes.
Because for salt dissolves in water, but sand won't dissolve in water. So sand won't affect the density of water. So we don't expect that to happen.
That is what I was
think she wanted to look at it from that angle, most probably.
That is why I was trying to probe her. That is why I probed her. Does it dissolve? No. How about salt? No. So that she answers her own question. But thank you, Mr. Chakon. So it will not affect it because it will not dissolve. It will simply sink at the bottom.
Okay.
I think we can continue. Akisa.
Excuse me, teacher, can mud or clay affect the of water?
Yes, please, Mr. Chakon.
Excuse me, teacher, can the density of,
yes.
affect the density of water?
Now, Abigail, and for all the rest, whatever can affect the density of water is that which dissolves in water. If you have any impurity that can dissolve in water, then it will affect the density of water. But if you add anything that will simply sink to the bottom, then it will not affect the density of water. I hope that is clear. So whoever is asking, if I add this one, if I add this one, if I add this, whatever you plan to add, if it can dissolve in water, yes, it will affect the density of water. If it will simply sink down to the bottom, then no, it will not affect the density of water. There are still more hands. Okay, Ashley Cole, probably the last one, and we'll move on. We shall pick the rest later. Ashley?
Yes, I have a question. Does the step affect the weather forecast?
Does what?
Does the step of the
I've not picked your question.
Does the step of the object determine?
Does the? We are not picking your question. Maybe you can type in the chat. Okay, guys, let's just do one.
The step of the object.
Okay. We're just saying, does the of the object? We can't hear you very well. Maybe type in the chat. Okay, now I would wish for us to just complete with what we had planned. Then we'll pick the other questions. So just save your questions. I'm seeing 4 hands up. Save your questions and we first complete. Then we shall get back to you. I'm now going to share the notes. So like I mentioned, you can try it out at home. Even those other things you're wondering, if I add clay, if I add this, if you have clay and sand in your vicinity, in your environment, you can try it out and see from first hand. Now here there is a question, does floating occur in air? Yes, please, Mr. Chakon. Yes, please. We can hear you.
Yes, I was saying that for the students' fun, and for their fun and for purposes of reinforcing your point, let them also try to put an egg in water, an egg in ordinary water. Then they get the same egg and put it in water to which they have added salt. Then they keep on increasing the amount of salt in that water. They will see what happens to that egg, and that's going to reinforce that point very well. Thank you.
Okay, thank you.
They get water less in a glass, put in a exactly the same point, which is the same experiment that is here, but they can use an egg. It brings out very interesting results.
Yeah, actually, this very experiment in yellow here is what you're explaining.
A boiled egg or a raw egg?
It's a raw
egg. A raw egg will work.
That is why they are telling you
don't boiled egg or a raw egg?
A raw egg, raw. So while you're stirring the salt, you make sure you don't break it. So that is a take-home experiment for you. Everyone who has an egg at home can carry it out. Over to you, Mr. Sengel.
Excuse me, teacher.
Okay, yes, Hope. Is it Hope? Hey, Gladys.
Teacher, can you first remove the egg, then you add the salt and stir, or you are strictly supposed to stir when the egg is in the beaker?
You can actually get 2 different cups or glasses at home. One with fresh water and another one with what? With the salt. You can even get 2 different eggs so that you really compare the 2. Different eggs that are somewhat the same size.
Okay. Yes, maybe if I could add something. Yeah, she can get fresh water in a glass, put an egg, then have another glass on the side with salt, certain amount of salt, then put it there. And then maybe have another glass, a third one, put even more salt, and then see what happens using the same egg. Or she could use different eggs. Either way to bring out the results. Yes,
okay,
even if they were of different sizes, the results will come out.
No, I'm saying eggs of the same size. They are usually those we can get of the same size. But she can use that.
But even if even if they are not of the same size, the results will still come out. But the same size will bring out better comparison, definitely.
Okay, so girls, we expect to get your experiences with that take home next time we meet.
Okay. Okay, girls. We now have that subtitle. Can someone read it for us? I'm going to ask the...
Does floating occur in air?
Continue.
Yes, please.
If a balloon is filled with gas, which is less dense than air, such as hydrogen or helium, it will go upwards. Meteorologists use balloons filled with hydrogen to find out about weather in the different parts of the world. Hot air is less dense than cold air. This is because everything expands when it gets hot. If the mass of air expands, its volume will increase while its mass stays the same. So its density will go down. Hot air will rise above cold air.
Okay. So, girls, we were here talking about balloons, and balloons have so many uses. Some of you at home, what do you use balloons for?
Excuse me, teacher, we can't hear you.
Oh, can you hear me now?
Yes.
Okay. I was saying we use balloons sometimes for our own functions. Can you give me some of the functions where you employ balloons? I hope you have had birthday parties.
Yeah.
And you know what you do with your balloon.
Yes.
What do you do with your balloons? I need one person to respond. Who will throw that person? You give us the response. There was a response.
Teacher, they can use them for decoration.
What exactly? Explain what you do with that balloon.
I think
you
around to.
You blow in air. You can use this pumping thing that people use on bicycles, or you can, I sometimes use my mouth, then I blow in air. After that, I get a thread and tie at like from where I've blown in air, so that the air cannot go out. Then after, I will start decorating.
Then what happens when you release the balloon?
When I've not tied it,
after I've tied
the balloon,
in the air, you release it. Then what happens to the balloon?
It will like if I release it, it will slowly go down. But
it will slowly,
yeah.
It will slowly go down or up?
Up.
It goes up. Is that okay?
Yeah.
So balloons, we blow in that air. I'm especially talking about blowing. And when we blow in, we realize that the air we blow in is warm air. Warm air is less dense than cool air, and that causes the balloon to rise because its average density is less than that of the air in which it is floating. So that's what we are talking about, floating in air. And apart from our decorations, there are meteorologists. Those are people who study weather patterns and so on. They use these balloons to carry scientific equipment, and that scientific equipment gives us the weather patterns that we see the meteorologists giving us, the patterns of the weather as what is going to happen, maybe in a day or in certain regions of the country and so on. We don't only stop there. For those of you interested in sports, balloons are used to carry cameras. You see always those overview of the field, those cameras are carried by balloons. They are used in tourism, especially in South Africa. Balloons are used for tourism. People go into those balloons. But the basic principle is that the air inside the balloon is usually warm, and specific types of gases are used. Anybody who can mention those gases?
Helium.
Helium and
hydrogen.
Hydrogen.
So those gases are less dense and they cause balloons plus its fabric to go up in the air. So flotation is possible in air. Okay? Is that clear, people?
Yes.
We're almost at the head of our time. Madam Nampa, just scroll down. I want somebody to read for us about the clouds.
Teacher.
Yes, please.
Can I read?
Yes, you can.
Rain clouds into brackets. Cumulus clouds often form over landscapes that have become very hot in the sun. So hot air currents are produced and rise upwards. These clouds carry a lot of water as they rise up in the sky. When they reach the high cold air, they form rain clouds from which we get a heavy storm.
Heavy storm. Is that okay? So that water, when they say a lot of water, usually that is a lot of water vapor. We are not carrying water, but we are carrying water vapor. I hope you understand when I talk about water vapor. Okay? And when that water reaches up there, it condenses and then it releases the rain, the columbus. So the formation of storm cloud, those cumulus clouds, we see how they come about now. And we see that they are caused as a difference in the density. Warm air has less density and it rises up. Cool air usually replaces it because it is more dense and comes down. So there is a form of current that has been formed, and this sometimes results into winds, as you are going to see. I don't know whether you get that point. There is movement of air, warm air, cold air, warm air moving up, cold air moving down. They form a certain kind of saturation, and those are basically our winds, which we refer to as currents. Is that okay?
Okay, well, thank you so much, Mr. Senjove. Our time is fast spent. Now, we've given you one first assignment regarding the egg in fresh and salt water. The other assignment I would want to give you is think about it. When we look at our houses or our homes, question number 1, do we have ventilators? Question number 2, where are the ventilators placed? In the middle, at the top, at the bottom? Then question number 3 would be, why do you think the ventilators are there? So that is take home about the ventilation in our homes. Where are they placed and why are they placed there and not elsewhere? So I think we shall begin from there. We need to allow time for these girls to rest and prepare for the next lesson.
Teacher, I have a question.
Mr. Zanapal.
Yes, please. Yes, Mr. Chakon.
Yes, I wanted that they can also go to the Google Classroom. I'm going to put there some small letter size with the numerical questions for their practice.
Okay.
They can go to Google Classroom. Yeah, I'm going to put there some small letter size with the numerical questions so that they can practice using the relationship dense mass volume, that kind of thing.
Thank you, Mr. Chakon. There was a question